there is a good chance that the AI products that you use today have been tested and graded by another AI. So it wasn't a human being that was checking every answer, but essentially a second LLM has been taken to read and score the outputs of the first one. And this is called LLM-evaluation or LLM-as-a-judge. And this should raise one question. Can we even trust such evaluation? Can we trust AI to create or test another AI reliably? By the end of this video, you should have a much better understanding of what LLM evaluation is, what it takes to make it more reliable and ultimately useful, and what are some failure modes for which you can go back and test your LLM evaluation if you already have one in your pipeline, and see whether there is some room for improvement and whether you should trust it. So let's start with why would you even need LLM evaluation? Why would you even need AI to be grading another AI? And the answer is that it really depends on the task. So for the tasks that have easily verifiable answers, such as a lot of math problems or coding, even though coding is a little bit more subjective, because if you're trying to evaluate implementation, there could be multiple equally good implementations for one particular task, one particular coding task. But let's say if it's some simple math problem where it's like 2 plus 3, yeah, you should really be using a calculator for that, but you get my point. Then for that answer, you don't really need to invoke the whole LLM to check it. You can just string match it or check for equality. But the thing is that most people use LLMs for tasks that have that are subjective and that are open-ended. So things like summarize this email, or help me edit this document, or help me prepare for the meeting. There are multiple good ways of accomplishing these tasks, and all of them are what's called natural language processing tasks. So you can't really string match for particular words or check whether particular phrases appear in the answer, because of course in natural language you can express the exact same thing in multiple ways. And so if you have such outdated approach, your evaluation probably doesn't make any sense. It's fragile, it's too rigid, it's useless. So what was happening before, and maybe still is to some extent, is that people were hiring other people to check the responses for such natural language tasks, to check them and score them according to some established criteria. And of course, as you can imagine, such process has been slow, it's expensive, you need to train those people, you need to explain the criteria, and it's just not very scalable. So when more powerful LLMs came along, of course, people got curious whether those LLMs could replace humans once again to do evaluation of these natural language responses. And short answer is yes, but as with everything in life, it brings its own trade-offs. So you get better scalability, LLM evaluations are much cheaper, but of course there are more failure modes. Some of them are actually also overlapping with human evaluations, such as consistency, reproducibility, and so on, for which you need to account for and you need to be aware if you want to make your LLM evaluations useful. So conceptually, what is LLM evaluation? It consists of 3 main components. The first one is the actual thing that you want to evaluate, be it its raw response from the model that you fine-tuned, or the response from your whole system that can have also rec, search, whatever inside of it. The second component that you need is the obvious one, the LLM-judge. So that would be just an LLM that you would be invoking with the response that you want to evaluate and with some criteria that you're going to specify, such that at the end it spits out some score. So it should be just a standalone LLM. It has nothing to do with your system, so to say. And of course, there are caveats. You can generally fine-tune that LLM as well to make it a better judge for your specific use cases, but that requires you to actually have high-quality data that describes your use cases and so on and so forth. So for the purpose of this video and for simplicity, just understand that it's a standalone LLM that has nothing to do with your system. And the third component that you need to have, and the one that brings most issues and also room for creativity and complexity, is the actual prompt and the criteria that you are going to supply to the LLM judge, such that your response gets evaluated according to the rubrics that you're actually interested in. And the first practical tip I can give you is that, especially if you're just starting out, is that keep it simple. Keep it to one rubric or one criteria only per prompt. Don't try to specify 5 or 10 different things that you want to be evaluated within one single call to LLM. It's just hard to debug, to reason, and to make it deterministic and reproducible. As your system evolves, maybe you will be able to merge some of those rubrics into one call. It depends on the scenario. But if you're just starting, my advice is to just stick to one concrete rubric, and nothing prevents you from invoking 10 different LLM calls, so 10 different charges, each with different rubric. So by rubric, I mean things like coherence, for instance. Is this response coherent? Or groundedness, which means whether this response is supported by the evidence or by the documents coming from your system, for instance. So generally, there are at least 2 ways to do LLM evaluation. One is pointwise, meaning that you supply the response that you want to evaluate, and you also specify the criteria and the range, so some scale from 0 to 5, for instance, how coherent this response is. But in practice, again, this doesn't work very well, because this, even though you might think that, oh yeah, range or scores are more deterministic, no, it's still ambiguous, because even if you think about humans, for one person something can be 4 out of 5, for another 3 out of 5, and even for the same person, if you show the same or similar response again, they might change their score, just because it's very hard to calibrate and be consistent within some range, even if this range is small. So in practice, what works better is either binary scores, so either this response is coherent or not, true or false, 0 or 1, or some really short range, like 0 or 1, 2, so 3 instead of 2 options, you give LLM 3 options. So, but this is when it comes to pointwise. Pointwise in general has its issue that it is pointwise. So it just by the nature of it, it's already a bit harder than something else, which is pairwise comparison. Instead of supplying just one response to evaluate, you supply 2 responses to your LLM judge, and you ask it which one is better, for instance, or which one is more coherent or whatever. And the reason why it works better is exactly because comparison is easier than using some absolute scale and applying it to response. But of course, it also comes with its own nuances. Like, first of all, you already need to have some established baseline or some production system, and maybe you have it. It's not a big deal if you don't, because either way, you need to start something. So how to deal with the cold start problem, I can talk in another video. The issue with pairwise comparison is something called position bias. So it's not necessarily that you will run into it. Again, it depends on your use cases, on your data, on the models that you use for llm-judge, on your prompt. But in general, this is something you should be aware of, and it's also sort of easy to check for. So position bias is essentially when the judgment of llm-judge changes because you flip the answers. Responses that come first in your prompt, they might be scoring consistently higher or lower than the second response. And the easy thing you can check today after watching this video is to just flip the responses and see whether you get significantly different score for whatever feature you have been evaluating. There are, of course, more failure modes when it comes to LLM evaluation. Judges can prefer longer responses, even if they are the exact same in terms of usefulness as some short ones. So this is just to name a few of the very common failure modes when it comes to LLM evaluation. And the reason for this is LLM evaluation is just nothing more than approximation of human judgment. So it's not a truth machine. It won't know better than a human being on average. Maybe it could know better than a particular person. To make LLM evaluation useful, what you need to aim for and what you need to check for is high agreement with human judgments. So humans among themselves sometimes might not agree, and that's fine. But on average, LLM evaluation, LLM judges should produce high correlation with human judgments. And the way you can do it is create a small sample data set with queries and expected responses, or with just queries. It can be nothing more than 30 or 50 queries. And then you can query your production system and let's say your experimental, just to have two things to compare, and record those responses from both parts of your system for all those queries. And then you can ask your teammates or someone to score which responses are better. And then you can do the same with your LLM evaluation. And then what you need to see whether there is a high enough agreement between humans and llm-judge. And the reason why it works is because there has been studies, and one in particular, which I will link down below, showed when there is a clear winner between two responses, one is obviously much better than another, there was a very high 85% agreement rate between LLM and human judgments. And so what it means is that it makes LLM evaluation practically useful. So of course it's not perfect, nothing is perfect, even human judgments are not perfect, but it's good enough and it brings all the scale and cheap costs that you can quickly speed up evaluation of your own product. I have been building and evaluating such systems, and this is exactly why I'm telling you not to blindly trust some score that is coming out of even super impressive frontier model that you use as llm-judge. You always need to do due diligence and create a data set, especially if you're starting from scratch and you have nothing, and then do the maybe tedious, boring work of annotating the responses that are coming from your system, and then comparing those human judgments or human annotations with what you get from the llm-judge. And only after that you can gain confidence that your LLM evaluation is actually practically useful. So in principle, LLM evaluations work as long as they approximate human judgments well enough. There are still many failure modes that could happen if you're building LLM evaluation for your own system or product. I will be covering more failure modes in the upcoming videos and how you can mitigate them or at least monitor for them. In general, this series and this channel is about how to make AI that you use or integrate into a product trustworthy and reliable and not just impressive. So tell me in the comments if you have been hearing some terminology or some concepts in your stand-ups or meetings and you still don't fully understand how they work under the hood or why they are needed. They might become the topics for the next videos. Thank you and see you next time.